Okay, this is the final lesson of definition of derivative, and we're going to cover square roots and tangent lines and normal lines. Okay, and in here we're also going to do Pascal's triangle one last time. Okay, so first let's get to doing square roots. Sorry, puppy. My puppy again is at my feet. All right, so the first thing we're going to do is we're going to write the definition of derivative, and we are going to show you how to do it with the square root. So I'm going to use a script H for the function, and that's the limit as h goes to t of script H of t plus h minus script h of t all over h. And the way we write this here is we're going to put the t plus h under the radical minus the square root of t all over h. Now, when we do this, what we do is we do what's called rationalizing the numerator, not rationalizing the denominator. So that means we multiply the numerator by the conjugate. So that's multiplying the numerator by t plus h plus the square root of t over the square root of t plus h plus the square root of t. Now I put this around with brackets around it because it just makes a little bit more sense to me with the square roots. Now remember that when I have a minus b times a plus b, that equals a squared minus b squared. So for square roots, that's going to be the square root of t plus h squared minus the square root of t squared. Well, that gets rid of the square root. So, and this is h prime. So this is script h prime of t will just simply equal the limit as h goes to 0 of t plus h minus t all over h times the square root of t plus h plus the square root of t. Then these t's will cancel, and I'm left with script h prime of t equals the limit as h goes to 0 of h over h times the square root of t plus h plus the square root of t. These h's will cancel, and that'll leave a 1. So here I'm left with the limit as h goes to 0 of 1 over the square root of t plus h plus the square root of t. As h goes to 0, this goes to 0, so I'm left with script h of t equal to 1 over the square root of t plus the square root of t, so that equals, so h prime of t equals 1 over 2 square roots of t. Okay? All right. So now, it's not that hard. You just have to remember that you're rationalizing the numerator. So now let's do it with a linear function. And again, on a test, I would never give you anything harder than a linear function. You should be able to do something harder than a linear function, but on a test, I would never give you anything harder than a linear function. All right, so f prime of h, f prime of t equals the limit as h goes to 0 of f of t plus h minus f of t all over h. So this equals the limit, this equals the limit as h goes to 0 of minus the square root of 5 minus parentheses t plus h minus the square root, okay, hold on, let me make sure I'm writing this correctly, minus parentheses minus the square root of 5 minus t all over h. All right? So before I multiply by the conjugate, I'm going to simplify this. So this equals, so this becomes minus a minus becomes a plus, right? So this becomes the limit as h goes to 0 of the square root of 5 minus t minus the square root of 5 minus t plus h all over h. So now I'm going to multiply by the conjugate, and the conjugate of this is the square root of 5 minus t plus the square root of 5 minus t plus h. And so that's the square root of 5 minus t plus the square root of 5 minus t plus h. Okay? So that's the limit as t goes to 0 of, the numerator becomes 5 minus t minus parentheses 5 minus t plus h all over h times the square root of 5 minus t plus the square root of 5 minus t plus h Now if I simplify, I get the limit as t goes to 0 of 5 minus t minus 5 plus t plus h all over h times the square root of 5 minus t plus the square root of 5 minus t plus h. H doesn't cancel out, everything but the h cancels out. So what I'm left with is the derivative equals the limit as not t, that should be h, that should be h. Okay. As h goes to 0 of h over h times the square root of 5 minus t plus the square root of 5 minus t plus h. The h's cancel and leave a 1. So that equals the limit as h goes to 0 of 1 over the square root of 5 minus t plus the square root of 5 minus t plus h. So f prime is t equals the limit as h goes to 0, and I'm going to take this h to 0, so if I take this h to 0, so then I'm left with 1 over the square root of 5 minus t plus the square root of 5 minus t. So my derivative is 1 over 2 square roots of 5 minus t. Boy, tongue twister. Okay, now let's look at the equation of a tangent line. The first thing we need to do is we need to find the point. So first, now you can do these in any order, but I'm going to try to keep them in the same order. So first let's find our point. So that means find f of negative 1. So that is 5 times negative 1 squared plus 3 times negative 1 minus 2. So that's 5 minus 3 minus 2, so that's 0. So I have the point negative 1, 0. Second, we need to find our derivative. So that means find f prime of x. So f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. So that equals the limit as h goes to 0 of 5 times x plus h squared plus 3 times x plus h minus 2 minus 5x squared plus 3x minus 2 all over h. So f prime of x equals the limit as h goes to 0 of 5 times x squared plus 2xh plus h squared plus 3x plus 3h minus 2 minus 5x squared minus 3x plus 2 all over h. I'm going to go ahead and cancel the 3x and the minus 3x and the plus 2 and the minus 2. So f prime of x equals the limit as h goes to 0 of 5x squared plus 10x h plus 5h squared plus 3h minus 5x squared all over h. So my 5x squareds cancel. Now I'm going to factor out an h. So that's the limit as h goes to 0 of h times 10x plus 5h plus 3 all over h. My h's cancel, and so I'm left with the limit as h goes to 0 of 10x plus 5h plus 3. I'm going to let h go to 0, and so that's 10x plus 3. All right? So my third is I want to find f prime of negative 1, which is my slope, which is 10 times negative 1 plus 3. So that is negative 10 plus 3. So that's negative 7. And that's my slope. Fourth, I have m equals negative 7. I have the point negative 1, 0. And I have y equals mx plus b. So I'm going to find the equation of a line. So I have 0 equals negative 7 times negative 1 plus b. So 0 equals 7 plus b. So b equals 7. So my tangent line is y equals negative 7x plus 7. And there's my answer. Okay? So now let's talk about Pascal's triangle, and then we're going to find the equation of a normal line. And the only reason I'm doing Pascal's triangle again is because we have a fourth degree, and I want to make sure that you get used to doing Pascal's triangle because it's an easy way to find the fourth degree coefficients. So Pascal's triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now all I'm doing to find those numbers is I'm adding the numbers in the row ahead. So this would be, if I'm using x plus h, so x plus h to the fourth is going to be x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus x to the fourth. Plus h to the fourth. There we go. All right, so now let's find the normal line. So the steps to finding the normal line are identical to the steps to finding the tangent line, except when we find the slope. When we find the slope, we find the negative reciprocal because the normal line is perpendicular to the tangent line. So we're going to find the tangent line slope, and then we find the perpendicular slope. So first, we find the point. So that's going to be f of 2. So that's 2 to the fourth plus 2 squared minus 1. So 2 to the fourth is 16 plus 4 minus 1 is 19. So that's going to be the point 219. All right. Second, we find our derivative. So that is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. So this equals the limit as h goes to 0 of x plus h to the fourth plus x plus h squared minus 1 minus x to the fourth plus x squared minus 1 all over h. Okay? So f prime of x equals the limit as h goes to 0 of x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth plus x squared plus 2xh plus h squared minus 1 minus x to the fourth minus x squared plus 1. Cancel alike terms. All over h. So f prime of x, I'm going to factor out an h, equals the limit as h goes to 0 of h times 4x cubed plus 6x squared h plus 4xh squared plus h cubed plus 2x plus h all over h. Cancel my h. Now, just to save time, I'm going to go ahead and let h go to 0. So this h is going to go to 0, this h is going to go to 0, this h is going to go to 0, and this h is going to go to 0. So what I'm left with is 4x cubed plus 2x. All right, so 3, I need to find my slope, which is f prime of x at 2. So that's going to be 4 times 2 cubed plus 2 times 2. So that's 4 times 8 plus 4. So that's 32 times 4 is 36. So this is my slope of my tangent line. Right? So my perpendicular slope is -1 over the reciprocal, which is -1 over 36. So this is my normal line. Okay? So then for 4, I have the slope of -1 over 36. I have the point 219, and I have y equals mx plus b. All right, so I have 19 equals -1 over 36 times 2 plus b. So then I have 19 equals -1 over 18 plus b. So then I get 342 plus 1 over 18 equals b. So 343 over 18 equals b. So my normal line is y equals -1 over 36x plus 343 over 18.